Hello, everyone. Thank you for joining us for another Tech Visionary interviews. This time we have a guest from all the way from Minneapolis, all the way from me, if it might not be from you. Hey, Lynn, how are you doing?
Hey, how are you doing? I'm doing great.
Great. Thank you. Thank you for joining us, dedicating your time for this short interview. Um, Before we jump into the topic, would you mind introducing yourself? Like, how did you get into the tech industry? What you do these days? What type of clients you help with?
For sure. I'm an independent. I run my own consultancy and it's project based. So it's me and then virtual teams all over the world. So I do both technical education. So I'm a contract LinkedIn learning author. I have 30 plus courses on cloud and data topics. In terms of production, I've been focusing my cloud building with the bioinformatics industry. So prior to the COVID outbreak, I was working with cancer genomic research. And now with the advent of COVID, most of my clients are focusing additionally on COVID research, COVID vaccine research. So it's been a really, really busy year.
Yeah, yeah. This this is definitely a busy year for that. That sounds interesting type of projects to work with, which can kind of relate to the topic we are going to talk about today, which is building genomic scale data pipelines. So when we talk about that, can you explain a little bit about like what you call a genomic scale data pipeline and how that can help businesses?
Yeah, I got interested in this vertical. I had worked on data and big data, and I've been in the industry for a while. So I was in 2007 to 2011. I was an employee of Microsoft. I wrote books on SQL Server. I was a SQL Server MVP after I left Microsoft, and I worked with a lot of SQL Server workloads and data warehousing. That's what I wrote my books on. So when I left Microsoft to go independent in 2011, it was the time of Hadoop and NoSQL. So it was a really interesting time. And at that time, I lived in California, and there was a lot of activity around social media startups and pretty big sets of data. So it was the big data time, right? So fast forward to now. Now, big data is passé. It's not even the thing anymore.
Mm.
It's genomic scale data. So what does that mean? Well, for one of my clients, the Broad Institute at MIT and Harvard, they are a nonprofit that focuses on genomic human disease research, primarily building these pipelines. They happen to run on the Google Cloud, and this is public information, but it's interesting to give listeners an idea of the scale. On average, they're putting in, this was before COVID, 17 terabytes per day. Per day.
Wow,
Yeah, that's the thing, right? Big data,
that's
genomic scale data, right? It's
that's
like
huge.
two different levels.
That's definitely huge. So when we are talking about that huge scale data, I don't think there are many like platform that can handle the compute and like the storage and things like that. What would be your options in those scenarios?
Yeah, I mean, there's whole different patterns. So, again, it was so interesting. I moved into this vertical based on a personal situation. A friend of mine got cancer and she was unable to get personalized treatment. She did survive, but she had very, very harsh chemotherapy. And my daughter at that time, who was then 17, happened to get the opportunity to go to Stanford in the summer. And she at that time wanted to do bioinformatics. And so she was taking a cancer genomics class at Stanford. You'd think the cutting edge, right? And so this is the same time when my friend was, having chemotherapy. And I knew from some other work I had done in San Diego that there was some immunotherapy available, but it wasn't available to her. And so, my daughter was learning about this immunotherapy, and she came home from Stanford and she said, God, these guys really aren't using the cloud. Because, being my daughter, she knew a little bit about the cloud, right? And I
Yeah.
said, I said, what? Are you kidding me? And so I really just pivoted my work at that point because I had been doing ad tech and fintech and, a bunch of other places that had really pretty big data, pretty big. The difference really is they might have had data almost to that scale, but most of those verticals were focused on fast, like it was going from seconds to milliseconds, right? So you could make that trade or get that ad out there. When I moved over to genomics, it's genomic scale data, so humongous amounts of data, but they're not used to fast at all. Like one of the first customers that I worked with, it was actually in Australia. It was CSIRO, which I'm sure you know, the big science organization in Sydney and other places. They had a workload that was running on-prem, and each time they ran one query, it took 500 hours.
500 hours.
Yeah, and they were like, "Can you do something about this?" And I said, "Are you kidding me? 500 hours? What? What?" And I had another client in London, and they were researching again some genomic thing for Alzheimer's disease. Their query took 2 weeks. It took 2 weeks, and it wouldn't finish half the time. So if you can get these queries down to like a day, they're really happy. So it's a different scale. You know what I mean?
Right.
It's a total. So the point is, genomics is really breaking ground in terms of the amount of data. And then, of course, you have the complexity of computation because it's usually machine learning, which increases the overhead even more because it's probabilistic rather than deterministic, right? So you have this double whammy of huge data and complex computation. And that's why you get 500 hours or 2 weeks or whatever. But what is fascinating is, as whether we like it or not, more of our world collects data constantly about us. Genomics is going to lead the way for building patterns that are going to be implementable or needed to be implemented in IoT, in other, in smart buildings and smart cities. So one of the reasons that it's so fascinating to work in this vertical is we're really setting the groundwork for the use of data in every vertical as the data volumes go up and as machine learning becomes part of more and more pipelines. So it's I don't think I've ever enjoyed my work more in my entire career. It's really difficult though.
That is really interesting, yeah, and definitely challenging in this environment. So working in such an environment, you should have really work on specifics. Like for example, if working with this language, with this algorithm takes like even 1 second in a normal situation more than something else, in the genomic scale that would be definitely hours. So what, let's say, specific considerations you have when you are working in that environment? You have like a list of things that can perform faster, or list of tips that you can make it faster for something like that? It is like a set of rules you go through, not the details, I mean high level.
For sure. Well, if you think of fintech, because I would think a lot of your listeners maybe are at least familiar with working in fintech because it's just common area for cloud, and they were early adopters of cloud and some of the advanced technologies. Fintech would build their own libraries and tools for speed, and genomics is doing that for volume. So you can use, and you will use, for example, if you're on, let's say, Azure, you'll use blob storage because it's a data lake pattern, right? But you're probably going to use something on top of blob storage to manage your costs, because in these genomic pipelines, for the first time for a lot of people, it's not just the compute that's the big part of your bill. It's actually storage now, which for many people, for the great majority of their workloads, they didn't care about storage because it didn't cost that much, right? But when you're working with 17 terabytes a day, suddenly you care about storage. And so sometimes the tools that the manufacturers or the vendors have put out there for the majority of the workloads, they're not quite good enough. So sometimes you have to write your own tools. Sometimes the industry will work together and write tools. It's almost kind of like the use case of Terraform. So a lot of us use Terraform, right, so that we can deploy infrastructure reliably across multiple clouds. So in bioinformatics, in pipelining, you're starting to see tools for cost management of data lakes. That is bioinformatics specific, right? Looks for, are your files optimized? Because the whole thing in bioinformatics is quality checks, because you're working with human material, blood or spit or whatever it is to analyze. And so depending on what you're doing, the whole thing in your pipeline is the amount of quality checks. Like if you're just looking initially and you want to just get a result fast in terms of bioinformatics fast, your quality checks might not be super extensive. But if you're building a vaccine Well, then for people, then you're going to have a lot of quality checks along your pipeline to make sure that your data is of the top quality, because you're basing human medical decisions on it. And so you might have to, have different tools and stuff to optimize your files, so that you can perform these quality checks. So
Great.
it's domain specific tools rather than raw services. And that's something I see as a pattern a lot. I saw it in fintech, and I'm seeing it even more in genomics, that people, especially when they're in university, they try to use the raw VMs, raw maybe Kubernetes clusters or something, and they have a really hard time getting value because their workloads are so computationally complex. So actually, like with the Broad, one of the things that I'm doing is, one of the aspects of the Broad's charter is to build these tools. So for example, they have a web UI. It's a tool set that sits on top of at this recording GCP. It's called terra.bio. And the idea is to abstract and to expose these tools through a graphical user interface, so the researcher can focus on the research questions while using the underlying infrastructure, right? And so from a research point, this is relatively unusual. Like if you go to commercial sequencing from like Illumina or one of the big genomics, you're going to use a portal, right? But the point is, even at the research level, and so to think more broadly, like if you just had a bunch of data from whatever source, typically in the past, you wouldn't have like a portal just for digging through the data at the research level. But what I'm saying is genomics has this pattern because you have to understand the value of the data before you even run it through the pipeline. So an analogy would be like IoT data from smart buildings. That's what's coming, I think.
Great. Thank you for that. What sort of industries you see this scale of data most with? You mentioned a couple of like IoT, bioinformatics, but what else?
Well, ad tech, whether we like it or not, all of our data is being aggregated. Health in general. So one of the interesting just things that happened is I happened to be in London when the first DNA store opened. It's called DNA Nexus, I think. I wrote a Medium article about it. But you go and you spit in a little thing and you get PCR testing. And what they're testing, it's like a regex for your genome. Assuming the audience, everyone know what a regex is. Genome is 3 billion letters. And so to be full GWAS or full genome sequenced is not something you get like in an hour. It still takes like a day usually. And it costs like $100 or $100 to $500. But this PCR test, it basically just looks for 8 locations at the store. And then they test to see, like, for example, how do you metabolize sugar, salt, caffeine? And then they put it with a Fitbit. They loaded into a Fitbit, and then they partnered with a grocery store. And then based on your activity, your genomic preferences in those 8 areas, and the food, then you get a red, yellow, or green when you go grocery shopping, right?
Interesting.
Yeah, isn't it? Right? So there's another one that is called Genome Palette that now tests, instead of 8 locations, it tests 128 locations. And so then they try to, they're always selling something, right? So they're trying to sell you like personalized vitamins. And, this is really controversial because there are some bioinformatics researchers like this is not, valid because they're only testing a tiny part and they're misrepresenting because, like, an example of caffeine metabolism, it's not just one letter, it could be like different places on the genome. It's just that you have one of multiple, right? So what's interesting about it is massive amounts of data and pulling out the individual values for human health. And that can be generalized to smart cities, smart buildings. Another use case that's really interesting, my brother is a judge, is cases like augmenting our legal system and our judicial system, which is super controversial, as it should be, right? But, taking anywhere where you have massive amounts of data. I mean, think about legal precedent, right? So the legal system. So augmenting what a lawyer can do with, a full review of every case, and then that being presented as part of the tools that the lawyer has. I mean, these things are just futuristic right now. They're not really there. But genomics is pushing this because In the example of COVID, of course, the world's trying to find a vaccine or vaccines. And so it's super interesting working as a consultant, being on these calls with 16 people from around the world, taking the whole life cycle of how COVID manifests in certain people's bodies and trying to understand genomically what that does. I mean, there's a project called the Human Cell Atlas, where they're trying to make an atlas of every cell type in human bodies, which is like,
That's really interesting.
I know, it
And
expands
should
it
be huge scale.
exponentially. Yeah. So
Yeah. Yeah, that's fantastic. Fantastic set of projects and examples you mentioned there. What is your advice to those businesses dealing with like this kind of data, but probably they had no idea this is called, like, let's say, genomic scale data. They are using big data technologies for that, and they feel the performance is not good. What they should do? What is their first steps to go towards having a better outcome?
well, I probably have a bias for education because I spend so much of my time teaching, right? But I do find, like people are needing to go fast. Like they were trying to go fast before, finding drugs for cancer, right? Now they're like really trying to go fast because of COVID. And you can't always go fast. Like, for example, one of my clients was building a pipeline for COVID testing, and they did a great job. And of course, we have requirements. We have HIPAA requirements here in the United States, but you can't shortcut security, for example, because it's human health data. So the advice I would have is there are certain things that you have to address. So you have to address the security of your data. You have to address forecasting. That's, I guess, a really important one. Like forecast the data volumes, because in sort of the old days of relational databases, we're just in a totally different volume level here. I have clients that have cloud bills that are hundreds of thousands of dollars per month in file storage, just file storage. So you have to get those
That's
basics right, and then you have to build this ladder. Like you can't just go to the production workload. You have to do hello world and then hello next world and hello next world. You have to build up to it, and you have to performance tune on the way up, because you can't get away with it works on my laptop and now I'm going to do it on a whole population. There has to be something in the middle, because otherwise it usually just times out. Because like I've had clients that have actually downed data centers. I can't say who or which ones they did, but they crashed the cloud data center.
because of that long running query. Right. That's great stories to know. Thank you. Anything else you would like to mention in this area that I haven't asked about?
Try to build on the work of others. It is in the research industry, research area. People are dependent on their grants, right? And so this idea that data needs to go in the cloud and then everybody can work from the data, it's still kind of new. People are used to kind of sort of hoarding their data, and that has to go away. So we can't wait anymore. The data has to go into the cloud. We have to figure out the governance. We have to figure out the metadata. These are hard problems, and we have lots of really smart people working on them. But we have to do this now, because you just can't. Like, I have clients that call me that are just like, and they're panicking because they're running out of capacity on their HPC, and they have backlogs and they have research backed up, and you have to go with those fundamentals. So it's all about the bucket. Everything is about the bucket. You got to get the bucket right. You got to get there's so many things. People are like, oh, the buckets are so simple. No, they're not. You have to know policies. You have to know the data ingress and egress charges. You have to know where the people are. You have to know how to set the most optimal data in, data usage. It's extremely important. So the data lake pattern, if I had to kind of like summarize it, know the data lake pattern for your particular vendor.
Great. Thank you. It was awesome discussion. Thank you. Really enjoyed it. What is the best way that our audience can get in touch with you if they have any questions?
Twitter. I'm on Twitter, sadly, too often. Yeah. I also have a whole bunch of sample code on GitHub. I'm really trying to publish as much reference as I can. And I've done some open source courses, notably GCP for bioinformatics, which includes screencasts, sample code, summaries. The Broad was a big sponsor of that, but the idea is to start to get these patterns out there so that we can support our researchers in this important work.
Great. Fantastic work. Thank you again for your time, and thank you everyone for watching us. Until next time, goodbye.